All right, we're on to day 2 for 3 linear equations. So in day 1, we talked about for being able to graph lines using slope and y-intercept. So we've talked about that. We talked about writing an equation, so not just graphing, but writing an equation using slope and y-intercept, and then being able to write an equation again, giving a slope and a point. So we want to go back over just for day 2 here, a few warm-ups to get us back in the groove here, and then we'll have a little bit more practice. So let's take a look at some warm-ups here. So I want to be able to go through and have you remember what all of these different things are. So the different forms of a line, but then also being able to identify some formulas and be able to do some calculations, and we'll practice a couple points. All right, so what I'd like you to do is go ahead, pause the video, write down everything you know about all of these formulas and relationships. So go ahead and write down what you think you know about these. You can go back and look in your notes too if you need to, and then we're going to run through what all of these are. Okay, so if you know two lines are parallel, what do you know about their slopes? They have the same slope, so their slopes are equal. So the slopes are equal for lines that are parallel. What do you know about lines that are perpendicular about their slopes? Their slopes are what? Two things: opposite and reciprocal. So they're opposite reciprocals. So that means if one is like 2/3, the other one would have to be negative, and then 3/2. All right, slope-intercept form. What is slope-intercept form of a line? That is y equals mx plus b, one of the easiest user-friendly ones for graphing a line that we have. Okay, point slope form, a little bit different form, but it's really helpful if we know a point and a slope, especially for writing equations. Do you remember what point slope looks like? So that's y minus y1 equals the slope, and then x minus x1. Remember, the x and the y are those variables that we hold, those placeholders for writing that equation. So having that x and y in there. And the x1, y1 is a specific ordered pair that we know from on the line. There's infinitely many ways we can write point slope equations for a line. When we solve it for y, there's only one slope intercept form for each line, which is really handy. So it just depends on what you're going to do with it. Both of them are graphing friendly. Point slope is really handy when we talk about writing equations. That works really well. All right, standard form. This is the one that we get it in a lot of times. Ax plus by equals c, where the a, the b, and the c are integer values. That means whole numbers are their opposites, like 5, -7, 58, whatever it is. And it's super handy when the a value is positive. That leading coefficient is not a negative number. Horizontal lines, kind of a special form. Do you remember what those look like? Y equals a number. So y equals some number. They said b, I believe, and a or whatever in that chart that we had, but just y equals a number. So like y equals 6. That's a horizontal line at 6. Remember what verticals are then. All the x values are the same, so x equals a number. Like x equals 7 would be a vertical line at 7. So that's a way that we'd be able to identify those. So all the different forms of a line, knowing what parallel and perpendicular are big ideas from this chapter, this section. All right, do you remember the formula for slope? Rise over run, slope formula. So rise over run, change in y over change in x. y2 minus y1 over x2 minus x1. So if I'm trying to calculate slope from ordered pairs, from points, I do the change in y over change in x. All right, how do you find intercepts, x and y intercepts, a place where they cross the x and y axis, these linear equations? Remember, we put in 0 for y and solve for x, and we put in 0 for x and solve for y. So this is when y equals 0, solve for x, and this is when x equals 0, solve for y. So being able to find those locations. Really handy way to graph lines that are in this standard form. It's actually a really kind of nifty way to do that. All right, so let's practice a couple questions here and make sure that we are understanding what we were doing from day 1 here. Write the equation of the line in standard form that goes through the point -2, 3, just cover the rest of those up so we don't get too much going on here, and a 0 slope. So the slope is equal to 0. Okay, so these are kind of things that hopefully would be easier, but they're kind of tricky to think about. If your slope is 0, what kind of line is that? Slope is 0. Well, that's when you have a horizontal line, right? So when you think about it, we should be able to solve and work through that. If you know it's a horizontal line, then you know it's of the form y equals a number. Well, if it goes through the point -2, 3, that has a y value of 3. That means the only thing that this could possibly be is something that has a y value of 3. So this equation would be y equals 3. There's no other option, because if it's a zero slope, it's going to be horizontal and it's going to have that y value. You could also use your slope-intercept form to help you, y equals mx plus b, and just put in your 0 for your slope and put in your x and y values, -2 and 3, and you can solve for b. 0 times -2 is going to be 0, and you're just going to get b equals 0. So the y-intercept is, oops, sorry, b equals 3. So with a 0 for your slope and a b value of 3, there's really nothing else it can be equal to. So that can be tricky for people, though, but think about what you know about zero slope. That means it's horizontal. All right, so another kind of special case that people struggle with goes through the point 57. So this is your ordered pair. Ooh, but with undefined slope. So that means the slope is undefined. What kind of a line has undefined slope? That is a vertical line. So if the slope is undefined, that is vertical. Might be handy even in your little chart to go back here. For horizontal line, we can say the slope is equal to 0. For vertical line, we're going to say the slope is undefined. So it's another way to identify what you're dealing with. So that means if it's undefined slope and we know it's vertical, that means it's x equals a number. How would you possibly know what the x value would have to be? Well, don't you have an ordered pair that it goes through? The only thing that x value can ever be if it's going through 5, 7 is the 5. So it's the x. So it would have to be x equals 5 if it goes through the point 5, 7. So I know that's a special case, but it is really handy to think about. If it's vertical or horizontal, we kind of know what the equation of the line is going to be based on the ordered pair we're looking at. So we can take a peek at that. All right, let's do a more conventional one like what you saw yesterday in part 1. Given the point 2,5 and it has a slope of -7, we want to write the equation. We want to get it all the way to standard form. All right, so we know a point and we know a slope. All right, so just kind of naturally thinking about our options for equations here. Slope, intercept, point, slope, standard. Point slope for me is going to be the easiest way to start this, so we're going to be able to write that equation. So I'm going to go ahead and just copy the formula over first. So y minus y1 equals m times x minus x1. And we're going to put in all the values that we have. We have an x1 and a y1. That's the specific point that they give us, and we have an m. So let's go ahead and replace all of those values that we know. So y minus our y value, just be careful that you grab the right number, that's the y value, and then the m, -7, and then x minus our x value, which was a 2. Now this is what we call point slope form. It's the easiest way to write the equation if they give us a point and a slope. Now we'd be done. That's an equation of a line. Awesome, finished. But they wanted it in standard form. So we just need to do some moving of terms. It's still the same line, but we can do some moving of terms. What I would do next is transform this into slope intercept next. Slope intercept form. And how would we do that? How do you get something into slope intercept form? You just solve for y. So that's the easiest kind of part 2 here to deal with this. So I'm going to go ahead and solve this for y. To get something from point slope into slope intercept, it's solve for y. So a couple things to do. The y isn't by itself, and we also have parentheses over here. So I would distribute first. So y minus 5. -7 times x would be -7x. Negative times a negative would be plus, so plus 14. So we're almost there. Then to get the y by itself, add, oh, that's supposed to be a 5. Add 5, that's a weird looking 5. So y equals -7x plus, looks like that'd be 19, wouldn't it? So that's slope intercept form. So we had point slope form here. Now we have slope intercept form, we solve for y. And again, this is just another way of writing the equation. Some people really like slope intercept form because there's only one way to write it for each line. This line has a slope of -7 and its y-intercept is 19. That is the line. There's infinitely many points on the line, so we could write infinitely many of these, but there's only one of those slope-intercept forms. There's only one y-intercept, one slope. Okay, we would totally be done, but again, they wanted it in standard form. So remember what standard form is. It just means the x and the y are on the same side, and we'd really like the a to be positive, greater than 0. It's just a little bit easier to read. All right, so we almost are there. the x and the y just need to be on the same side, and then the number on the other side. So because the x is negative where it is, I guess to get it into standard form, get that x and y on the same side, I think the easiest thing for me would be to add the 7x. Now, x and y aren't like terms, but what that accomplishes is we get 7x plus y equals 19, and we have our standard form. We have the x and the y on the same side. The x is positive and everything's a whole number. If you still had fractions or something in this situation, what I would do is go ahead and just multiply through by a common denominator to get rid of the fractions if you need to. Hopefully we won't have lots of yucky numbers like that, but you definitely could in a real situation. So just wanted to go through some of the big ideas again from this section 3 and then the rest of the chapter a little bit as well to really solidify what we know about linear equations and how to work with them.